Today we'll look at an example of an impulse change in momentum problem. We have a car speeding along at 35 meters per second, and then the driver hits the brakes and it says it skids for 3 seconds. So obviously the speed of the car is going to decrease, and it tells us that the coefficient of friction is 0.6, and we're looking for the new speed. So when I look at this problem, I realize I've got the car, and their initial momentum is this way, to the right, so that's positive. And then for a period of time, he's going to hit the brakes. So friction is going to go this way, so that means that the impulse is actually going to be a negative value. And then when the car after the car has undergone this change in momentum, it'll have a new momentum, but it appears it'll still be in the positive direction. Okay, so to solve this, let's just set up the impulse change momentum theorem, which says that Pi plus the impulse equals the final momentum. The initial momentum would be the mass of the car times its velocity plus, well, we know this is actually going to be a negative number because it is a negative impulse. The force is friction, and then it was for 3 seconds, and then that'll be 1200 times the final velocity, which is what we're looking for. Well, just off to the side here, we know that friction is still fun, even in impulse problems. So, and in this case, since it's a flat road, we see an example where the normal force would be the same as the weight, so friction is mu mg. So the friction force will be 0.6 times 1200 times 10, and so that's going to be 7,200 newtons, which will be in the negative direction. So I'll plug that in over here. So now we have, let me work out a little bit of the math here. This will be 42,000 kilogram meters per second minus 7,200 times 3 equals 1,200 VF. 42,000 minus 21,600, 1,200 VF. 20,400 kilogram meters per second equals 1,200 VF. VF obviously is then 20,400 over 1,200, which works out to be 17 meters per second.